Number 78 says, suppose you lift a 20 kilogram box by a height of 1 meter. How much work do you do in lifting the box? Instead of lifting the box straight up, suppose you push it up a 1 meter high ramp that makes a 30-degree angle with the horizontal angle as shown. Being clever, you choose a ramp with no friction. How much force is required to push the box straight up the slope at a constant speed? How long is the ramp? Use your force and distance results to calculate the work you do in pushing the box up the ramp. How does this compare to your answer in part A? Okay, so for the first question, how much work do you do in lifting the box? So we can express work as W equals the mass times the acceleration of gravity times the height of the object when it's raised. And so we can calculate what we know these to be. So the weight or the mass is going to be 20 kilograms times acceleration of gravity, 9.8, times the height it is raised, which is 1 meter. And that equals it's going to equal 196. We can call that joules. Okay, then to just convert that to kilojoules, which we want, we can just divide that by 1,000 equals 0.2 kilojoules. Oh, let's see. No, that's not right. 1 kilojoule is going to equal 1,000 joules. There we go. Now if we do that, we get 0.2 kilojoules. Okay, that's part A. Part B, the force required to push the box straight up the slope. So let's do this. A equals 0.2 kilojoules. So the net force acting on an object is 0 and has no motion or moving with constant speed. So the net force, you can say, is 0. Net force is 0. And so the net force on the table is horizontal direction is 0, and it is moving with a constant speed. So we can go F minus mass times gravitational acceleration, sine of 0. And then we substitute for mass, which is 20, 9.8 for the gravity, and 30 degrees. So F equals, if we add these up, it's going to equal 98 newtons for part B. So you can see that. Okay, part C, the lengths of the ramp can be found out from the figure. Okay, provided. Oops. So we can take the angle that they give us, which is 30 degrees. And that is going to equal 1 over D. Which is the hypotenuse angle of 30 degrees, which is sine do that. That equals 2 meters. So the length of the ramp is 2 meters. It's part C. Part D. Let's see. Part D says use your force and distance results to calculate the work you do in pushing the box up the ramp. Okay. So work done by applying force, we can show by saying W equals force times angle times S. We want to substitute 100 N for F. 100 newtons, 2 meters times 0 degrees equals an even 200 joules. And then convert that to kilojoules as 0.2 kilojoules.